back to the beginning. Remember that the whole reason that we went into this rigmarole over vectors and trig was because we were trying to evaluate concurrent forces, forces that are happening at the same time. And what do we do when these forces aren't easily matched up? So on page 64, we have an example that hopefully is going to bring all this together. So let's go through the example. We have two bungee cords attached at a common point. Bungee A pulls with 5 pounds of force at 0 degrees. And bungee B, 3.5 pounds at 90 degrees. And the way we schematically represent that is we do this head to tail schematic. All right. Now, these vectors should add up to a resultant vector like so. Now, when you are drawing these vectors of force, this is in boldface on the page, always draw the horizontal vector first, beginning with the origin. All right. By the origin, recall this from your high school algebra days with a Cartesian grid. This is the origin right here. All right. So draw from the origin horizontal vectors first. If you do that every time, you won't go wrong. All right, so we're going to calculate the tangent of the unknown angle theta. Remember, tangent equals opposite over adjacent, which in this case is 3.5 over 5, and I'm pretty sure that's going to come out to exactly 0.7. So, we'll use the reciprocal function of tangent. And that gives us, rounding to the nearest tenth, 35 degrees. Using trig, we know that hypotenuse equals opposite over the sine of the angle and or adjacent over the cosine of the angle. So we're going to select the first trig formula just because it's first. So hypotenuse is going to equal opposite over the sine of 35, which is 3.5 over sine 35. I have 0.574. And we divide that. 3.5 divided by 0.574, 6.098. Thus, the sum, or the resultant, of the forces of the two bungee cords is 6.098 pounds at 35 degrees. All right, we'll pause here, and then we'll go on to a few more examples.